being there with me. And where's my friend Lewis? Harvard's like, I don't know, or do I care? Yes, so if you could put the test corrections, what's the order that I want? Let's do corrections on top, then the test, then the reflection on the bottom. Just staple that together.
Is it okay if I do the corrections and the test?
That's fine.
Okay.
That's fine. Alright, so, yay, it's Thursday, which means tomorrow is Friday. And then after that, 2 weeks left until Thanksgiving break. I will tell you right now, if all goes well, there will be only one thing I'm going to ask you to do over the Thanksgiving break. Just one thing. Which is going to be take-home test. Take-home test is going to be the one and only thing that I'm going to ask you to do. Over the winter break on what we're studying right now, definite number, which should be a really good thing for all the friends. It is possible, and I'm going to do my darndest to try to arrange my schedule so that I can be here on campus that Friday afternoon so that those of you that just want to take the test that day and get it over with have that opportunity. How many of y'all are thinking that that would be a good thing? It wouldn't happen in class, it would be like an after school, just stay 50 minutes, get it done. I think that would be a smart thing. No, I'm not coming up on the Saturday, no.
Unrelated question, do you have a Band-Aid?
Do I have a Band-Aid? No, I don't even have a heart or blood, so I can't bleed. Okay, I believe that there's a Band-Aid somewhere in my desk, go look for it. Alright, I want to give you guys the next 8 minutes to ask any questions that you might have about the amusement park problem that's due tomorrow. I wrote this, I rewrote this to make it a little bit more challenging for you all. I'm so excited about this. How many of y'all have actually started on this problem?
What is that?
I tried.
This is the assignment that I gave you guys yesterday that I said is due Friday. That this counts as a double homework assignment grade. It is the last grade for the 6 weeks.
So do it right?
So do it and do it well. I was hoping more of you would have started it already, and this is not me putting you on a guilt trip. It does sound like it, but that's not actually the intention. You guys are free from. Do whatever you want. Make bad decisions. What do I care? Okay, Lyra?
Are the answers going to be like 1,000?
The answers are going to be large numbers. The answers are going to be large numbers. So, okay, so here's the thing. Here's the thing that we're talking about in this situation. If you haven't looked at it yet, well, this may not make a whole lot of sense. We've got this amusement park, and in this amusement park, people are coming into the amusement park, and as happens in an amusement park, people are leaving the amusement park. Everyone's still okay with me, right? E of T is a rate of entering. Okay, so this is the rate that you're entering, and this is going to be in people per hour, and when you read the problem, it'll make a lot of sense. L of T is the rate people are leaving, also in people per hour. And then I start asking you to figure out the total number of people who enter the park during a particular time period, or the total number of people that leave the park in a particular time period. And all I've given you are some data values. You're asked early in the problem to make a graph of like time versus like E of T, which is in people per hour. And you've like plotted some points. I'm not ruining any of the fun. This also isn't what the graph looks like. You're asked to figure out the number of people who enter the park during a particular time period, like from like 9 a.m. to 1 p.m., which is T equals 13. Is everybody okay? If E of T is the rate that people are coming into the park, the rate, not how many are coming in, but how fast they're coming in, then my argument would be that if I find the area, that this area represents the total number of people that come into the park. My question to you all is, why is that true? If you were to find the area Why is that answer telling you the number of people that have come into the park? Myra.
I don't know how to fully explain it, but with the velocity time graph.
Okay.
We have speed,
Okay.
velocity, and the area's displacement.
Okay, so you're having some like physics thoughts here that like when I look at velocity graph, velocity is a measure of like how my position changes. And so when I find the area under there, what you get is displacement, which is total how much my position changes. So you go from a graph of a rate function to finding the area, and what you get is a total. That's one way to think about it. What if what I told you guys is, like say at this point right over here, that this is the point 9, 100. That means that at time t equals 9, people are entering the park at a rate of 100 people per hour. The area, if I'm going to go from 9 a.m. to 1 p.m., the length is 4, the height is 100, the total area is 400. Why would I ever interpret that 400 as meaning 400 people came into the park? One person. You've got a 4-hour time interval. Andrew, what are your thoughts that you have back there?
I was saying that, but is it because, like, in an hour, 100 people were entering, so on?
Yep. So you want to interpret this point as 9, 100 means that at time t equals 9, people are coming in at a rate of 100 people per hour every hour. If I'm going to approximate this with a rectangle, what you're saying is, well, that happens not just at time t equals 9, but for a total length of 4 hours. The height of this rectangle is 100 people per hour. What you're finding is area. How do I find area? Length times width, or base times height. 4 hours. 4 hours times 100 people per hour has to be. The hours cancel out, and what I get is 400 people. Everybody kind of okay? Now, it's not going to be one great big rectangular block. You're going to use Riemann sums. You're going to come up with approximations because those are just going to be rectangular slices. You're going to get a lot of practice with Riemann sums doing this. It's all calculator active. I don't want to just see naked numbers though. I need to see the work. Are all the friends okay?
Yes.
This is due tomorrow. It counts as like 2 homework assignments. Get it done well, don't blow it. Alright, so with that said, enough with the amusement park. I know some of you are hoping we were going on a field trip. Sorry.
I was.
Sorry. I did that once. It was a whole lot of fun. We went to Six Flags. It was great. Six Flags, it's gone.
I really wish we like lived in San Antonio.
I wish you lived in San Antonio as well.
I'm glad I lived here.
Not you personally, Celeste. Alright, so here we go. Theme for today and tomorrow is we're going to go deeper with the definite integral. We're going to look at properties of the definite integral. And in a math class, when I say a property, I mean something that is true all the time. I'm on page 21, properties of definite integrals, day 1. Okay? Yeah, of course you missed something yesterday, Aaron. I taught. Okay. The definite integral, it's just a little bit of background knowledge here. Let's make sure that all the friends watching at home know what's going on. I'm going to turn around. I need some brave souls with their hand up there. How would you read that notation?
Oh boy.
I knew it was going to be Celeste and David. Aaron, how are you going to read this notation?
The definite integral of f
Definite
of x
integral.
with respect to x.
Of f of x with respect to x.
Yes. Isn't it from x equals a to x equals b?
From x equals a to x equals b. A is the lower limit, b is the upper limit, and the meaning of this definite integral, Eileen?
You're going to find the area between the x-axis, the graph of f of x, and vertical lines from x equals a to x equals b.
Is everybody okay with the meaning? Okay. So we know how to read it. We know what it means. It's always going to mean area. Area, 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 area. It'll mean area until I say otherwise. There are other meanings, but for right now it means area, area bounded by 4 things. Polymon, what are the 4 things again? Area bounded by 4 things. They're all here in the notation. And I just said them while you were enjoying your lollipop. Okay, your 4 things are.
Oh, I know.
The vertical lines x equals a and x equals b. The graph of f of x and Aaron and the x-axis. All the friends are okay. Okay, Carmen's getting ready to go over and slap some people over there. All right, so if that's what the definite integral means, there are also some properties that come along with this definite integral. When I say properties, I mean something that is always true. Another word for property, you also know this as identities, things that are always true. Anybody think of some mathematical identities? Mathematical identities, things that are always true. Oh my gosh, Mr. Link is so sad right now, he doesn't even know why. Nobody can give me a single identity. Carmen. A squared plus B squared equals C squared. Now I want to be careful because that sounds like out of context. It means like, oh, anytime I see the letters A, B, and C, A squared plus B squared equals C squared, but the A, the B, and the C means something specific, right? And we all know what they mean.
Yes.
We're talking about the Pythagorean theorem, which is not always true. It's not just like A, B, and C. It has to be in a right triangle. So like this is a property of right triangles. Everybody okay? If you no longer have a right triangle, then this is no longer true. Okay, some people like to think, well, there are other properties. For example, the absolute value of x is always greater than 0. Is this a property of the absolute value?
Yes.
Always true?
Always.
False. It is not always true. There's a reason why that's not always true. All you need is one counterexample. One time when it's not true to be like, not true. Stephen.
0.
Okay, 0. Can you do that? How about a sentence?
Always.
This is not an identity. It's not a property because...
It is not an identity or a property because if x equals 0, then...
If x were to be equal to 0, the absolute value of 0 would not be greater than 0. Are we okay? Make it a property of the absolute value by saying greater than or equal to, and everybody's okay. Everybody good? Okay, how about this one? Sine squared theta plus cosine squared theta equals 1. Always true? This is a property. This is an identity would be another word. Okay, how about this one? Square root of x squared.
Whoa.
What about it?
You're frozen. Square root of x squared equals x. Always true?
Pretty much.
2 people? Always true? Always true? If I'm pausing for this long, it must not always be true. You guys are figuring me out. This isn't a property. Why, polymorph? Think about negative numbers, right? If you're like, oh, positive numbers, sure. 5 squared is 25. Take the square root of 25. You guys are going to tell me the answer is 5. Start with negative 5. Negative 5 squared is 25. Square root of 25 is 5. Not negative 5. Everybody okay? This works for fractions. This works for decimals. This works for 0. This is not a property that's true for negative numbers. So what sometimes we say, like with our properties, you might say something like, for x values greater than or equal to 0, is this a property?
Yes.
Sure, as long as my values are greater than or equal to 0, then this is true. Theme for today and tomorrow is to figure out what properties exist with the definite integral, and which ones actually are not properties, but you're just going to fall for them anyway. So let's look at this first one. We're going to do one together, and then I want you guys to play a little bit with this. All right, statement number 1. For constants A, B, and C, where A is less than C and C is less than B, the integral from a to b of f of x dx is equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. Have a conversation with somebody near you. Does that appear to be always true? If you think it's always true, then it must mean we're going to be able to prove this. If you think it's not always true, then come up with a counterexample. My goodness, you guys are shedding over here this morning. In case this teaching thing doesn't work out, I can go work at Luby's or something.
No matter what.
Yeah, because it's like the whole thing, so then if you like divide it up, like if you divide the area in half, half of the area.
All right.
That's total.
Okay, quick show of hands. How many of you guys would say that this is actually a property of definite integrals? This works. This makes sense to you. 1, 2, 3, trust your instincts. 4, 5, 6. How many of you guys think, no, this is not going to be true? How many of you guys have no idea? Be honest. Thank you for the honesty. One way that you could go about proving this, draw a little picture. Right? I know what this means. We've already had the conversation. It means I've got a function. I want to find the area from A to B. Here's my function. Here is A. Here is B. The total area is represented by this integral from A to B of f of x dx. The expression on the right says the integral from A to C of f of x dx plus the integral from C to B of f of x dx is going to be equal to the same thing. Well, where's C? C is somewhere in between, Not out here. C is like somewhere in here. If I were to find the area from A to C, which is what this guy represents, and add it to the area from C to B, which is what this guy represents, is that equal to the total area from A to B? Everybody okay with this? So I would agree that this is indeed a property. Sometimes properties have names. I'm not really sure what name this one has. Maybe it's Bob. Everybody okay? All right, try the next one. Either come up with some visual example of why you think it's true, or show me that it's false. If you think it's wrong, give me a counterexample or some reason why this isn't true. So it's not a property. There you go. All right, from eavesdropping on all the conversations, if you go with a graph that looks like this, then it's a property, right? The key, though, to find the counterexample, what do you need to do?
To the negative.
Pick a graph that has some negative area. Any amount of negative area would do it. Maybe you're like, oh, like the sine graph. If this is your graph of f of x, here's x equals a, here's x equals b, it doesn't have to be those values. We know like this area counts as positive, this area counts as negative. But if I say consider the graph of the absolute value of f of x, what's different? The negative part gets reflected up above the x-axis. And this area over here is going to have to be greater. Everybody okay with that? You guys know how we're playing the game here? Okay, so not a property. All right, see what your smarticle particles tell you to do at number 3, and then I'll get out of the way. Yes, that's a K. K is a constant. K for Keith.
That's terrible. Yeah.
K for killer clowns.
It's November. It should be on.
K for killer turkeys.
There we go.
Let's keep it seasonal.
Homework from this week.
Andrew, Carmen, and Giselle, and Aaron, if you have the homework from yesterday, just put it in the little table up there. Not seeing as much progress on this one right now. For all constants k, the integral from a to b of k with respect to x is equal to k times b minus a. Okay, curious, how many of you guys would say, yes, this is true? How many of you guys think it's false? How many of y'all have no idea how to even begin this problem? Okay, thank you for the honesty. All right, what do we know about k?
Constant.
Constant, graph a constant.
Line.
Graph a constant, what's gonna happen? Andrew's got it, he's like, it's a constant. This is the line y equals k. Now maybe k's down here, maybe k's up there, who cares? Okay, k is a constant. The definite integral, the expression on the left says, find the area. Find the area bounded by four things. The function, the x-axis, and two vertical lines. One of them at x equals a, one of them at x equals b. And it says find the area. Okay. I think we even have a name for that shape. It's a rectangle. How do I find the area of a rectangle? How do we find the area of a rectangle forever? Length times width, or base times height. How long is the base? How long is that base? It's b minus a, isn't it? What's the height?
Crazy.
The height is determined by k. So guess what? Your area is going to be k times b minus a, which means this is going to be a property. Okay. This one, I would put a little star next to. Oh my God, you're going to use this one again and again and again and again and again. Some people might already even know it because that's how their brains work. All right, so your goal in the next 14 minutes is to figure out statements 4 through 8 on the back. How many of those are actually true? If they're true, give me some sort of a visual argument. If they're false, the only thing it takes in mathematics to show that a property is false is one counterexample. One time where it doesn't work and everything falls apart. We'll talk in a little bit. So now here's what
Okay,
be
let's
careful.
say f(x).
You haven't proven to me yet that that actually is true.
So f(x) is 2x and then g of x is.
And that will allow you to distribute the integral over addition. This,
And the area would be the area.
this is going to be a really nice property that we're going to see. But I need you to just work with comments.
No, you're saying like
5x.
Thinking about
plus, you said plus 2x,
graphically
you
what
said
was
2x, right?
2x and 3x.
2x and 3x? Oh, so 5x.
Yeah.
But then that's different than the area
Then
of
saying
2x
2x
plus.
plus 3x, yeah. Different than saying that.
Right.
It might, I think this would be a higher value. Before on this maybe that. But up there, yeah. But I was saying, what if one of them is negative? Like, if you have a negative function, like, so you have,
We only need one counter.
that's what I'm saying, but you use a negative. What if one of them is negative, but the negative function is higher?
So the instincts are saying this is probably appropriate.
The negative one separate isn't as high as the
Okay,
positive.
but the question is like, how would you actually go about proving it?
Positive value on one side, negative value on the other.
So the expression on the left says the integral from a
I know.
of f of x plus g of x. You have like two functions that are being added together. And I'm asking you to find the area. Is that the same as finding the area bounded by the first function, then adding on to that the area bounded by the second
If
function?
negative and negative will still end up
But
being.
only one's
If only one's
Yeah,
negative.
you're finding something this one.
So some people have been like drawing some graphs like what if the function looks like this, what if the other function looks like this, like what would happen?
Okay.
That's gonna be a good way to go about it.
I can see it.
Like, you're glaring at me like you're hoping your heat vision's gonna kick in. Just burn me. So what do you guys all about?
We think. Okay. She thinks yes. We think
But
no.
I don't think
I
that.
think also kind of, I see both ways.
You see both ways.
I was thinking no, because what if you have a negative value, a negative function that's one of them?
Okay. I'll tell you, statement number 4 is true.
So it is like.
It is true. And the way you might want to think about statement number 4, Stephen, if I'm over here, can folks see me? Okay. So the black graph, we'll call that f of x. This blue one, we're going to call g of x. Okay. So here's x equals a, here's x equals b. The first integral says, the first integral on the right says find that area. The second integral on the right says find all of that area. The question is that the same as if I were to draw the function f of x added with g of x? And what happens, and this is more of a pre-calculus thing that you guys may or may not have talked about, at every single point, like here at x equals a, the graph of f of x plus g of x is this height added with this height. So what happens is like the y value here gets added with the y value here, making your new function even taller than it was before. Like this is the point on f of x plus g of x. It's made up of whatever the height was of f of x, added to whatever the height was for g of x. You just take the y values and you add them on top of one another. And what happens when you do that again and again and again, all the way from x equals a to x equals b, you're really just getting like these graphs stacked on top of one another. I don't know that I explained that as well as I wanted to. Here's the thing, it's true. I think you guys are going to do better with the other ones. What's up?
The way that I saw it, that
Yep.
I feel like can help me, is like if thinking about logarithms. When you're just adding them up, just basically expanding the equation.
Yeah, but you want to be careful because if you're thinking about logarithms, not logarithmics, that'd be like a good band, I think. Okay, logarithms don't have this property. Stephen and some other friends in the back were like, oh, it kind of looks like I'm taking this integral and distributing it, saying like it's the integral of this guy plus the integral of that guy.
That makes sense.
That is true, and it is something that makes sense, and it's actually true. That's the important thing. All right, see what you can do with the rest. I think the rest are going to go much better.
Oh, I found it. I just remember seeing it.
K is still a constant in number 5, sorry.
6 is true.
Well, that's not what we're
Okay, 6 is true. because-
Celeste, stop being a mean girl. Stop just telling them all things.
No, we already
Oh, sorry, that,
We
yeah.
already knew that. We knew that like first day.
Yes, you did.
Five is smart. You said 5 is smart?
You'll go from like to left. I mean, 5 is false.
Oh, wait. Because you're saying that doesn't integral with respect to, I mean, of K,
It could expand past this one.
but now you're saying this whole thing, now you're saying this times K. Before it's the definite integral of. Yeah, but now you're taking the area of the function, multiplying 5 there. Instead of taking the
So what
area.
are we thinking about number 5? Is the integral of a constant times my function the same as constant times the
Because
integral?
we already learned it.
Think about this from an area standpoint. If I take the y values of my function and multiply by a constant, well, what happens to the function when you multiply by a constant? Well, depending on the value of the constant, right? If k is positive, it stretches your graph. Right? If I'm sorry, positive and greater than 1, it's going to stretch your graph. What's going to happen to the area? If you're vertically stretching the graph, you're going to get more area, less area? You're going to get more area. You're going to get not just like some random amount more area. You're going to have like this multiplying effect on the area. If the graph is 5 times as tall, there's 5 times as much area. If it's 10 times as tall, 10 times as much area.
Goes from negative a to a, it's negative and positive, so this would cancel out to 0. But if you take 0 to a,
What did you guys say? Right, number 6 is true. This is one of the things I told you guys in the beginning. But like visually, what's happening here in number 6?
you're flipping the direction.
The direction, yeah.
Right, it's the direction that's changing. You're saying here's A, here's B. Right, go from B to A. Go in the reverse direction, you take the opposite area.
The statement 5 false.
Statement number 5 is actually true.
Is true.
Why? Yeah. 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 Dude, we can talk about an example here. Right, if you multiply a function by a constant, imagine like a positive constant bigger than 1. So like 2 times f(x), 5 times f(x), what happens to the graph?
It just expands.
It expands vertically. We're not doing anything horizontally, you're just saying stretch it
Which is
vertically.
the same as changing the height.
Which is changing the height of it, and if you're changing the height, you're also changing it. Right, you're changing the height, you're saying at every single point make it k times greater, 5 times greater. Now what if k is a small number? 0.5. You're shrinking.
With the rule still applies.
And the rule would still apply because you're applying that to every single one of the
So it's
heights.
like you're only changing the height.
Right. What if k is negative? If k is negative, what happens? Think about what happens to the function. If k is a negative number, you're taking your function,
Oh, you're stretching it, but then
you're
you're
stretching it and
You're
flipping it over the x-axis. And if you're flipping over the x-axis, you have negative area now because you're below the x-axis.
Because your constant is negative right here, which is like this. So like
Yeah.
constant is negative.
What if k is equal to 0?
Constant is something.
Oh, because then they're multiplying it times 0 with the height. No, you have no height.
Yes,
So there is no area.
We have no area.
And
Depends on your constant.
Exactly, and I had my solutions and they're back here. All right. Here we go. Spoilers, here they come.
Cool, buddy.
Hey, I try. Except I probably wasn't the buddy you were talking to, right? All right. Number 5 is a property. It is a property, and if you're just looking for like what's the nice way to think about this, if you have a constant inside the integral, what this property allows you to do is basically factor the constant out in front of the integral. I had some conversations with 2 of the 3 groups about thinking about k as like what you're doing is you're stretching the height of the function, and if you're changing the height of the function, you're changing the area. Think about it with all the slices. Number 6, the integral from a to b of f of x dx is equal to but opposite of the integral from b to a of f of x dx. This is actually, as Aaron was saying, it was one of the things we talked about on like the very first day. The way I want you to think about it though is like, if you're going from A to B, right, you're going left to right and you're getting a positive area. When you switch your limits of integration, you go from B to A. Now you're going to get a negative area because direction's important with the integral. Everybody okay? All right, number 7. For any function f of x, the integral from negative a to a of f of x dx is equal to 2 times the integral from 0 to a of f of x dx. I know not everybody had a chance to get to this one, but think about that for a second. For any function f of x, if I take the integral from negative a to a, is that equal to double the area that I get if I go from 0 to a?
Oh, I get it.
How many guys would say this is a true property? False property. And you can think of at least one counterexample. All I need is one counterexample. For example, sine function. Or how about any function that doesn't have this nice symmetry property? Okay. Number 8 says for any even function, even, the integral from negative a to a of f of x dx is equal to 2 times the integral from 0 to a of f of x dx. Even function, the thing I need you to remember here, even function means y-axis symmetry. Y-axis symmetry. These are even functions. Can I get some examples of parent functions that are even? X squared. You're frozen for a little bit. Y equals x squared is a parent function that is even. Y equals x to the 4th is another example of a parent function that's even. Do not tell me x to the 6th, x to the 8th, x to the 10th. I got all those. Other even parent functions. Carmen? One more time. Y equals cosine of x is an even function. You start at the max and you drop down on both sides. So this property works there. Other parent functions that are even. There's more that I need. There's more that you know. We've taken out x squared, x to the 4th, x to the 6th, x to the 2n power. We've taken out cosine of x, even?
Absolute value of x.
The absolute value of x, even function. Anybody know any other even parent functions? I can think of 2 more that I'm hoping are going to come up here. Which one? Okay, Myra, why don't you do it in the air again? Maybe somebody can help you out. What one is that? 1 over x squared does that. There's one more even parent function that I'm hoping people are going to come up with. I'm just doing something. All the kids at North Central and East End are paying attention to me right now. 1 over x squared plus 1. The hill is an even function. Okay. Okay, so for an even function, is it true that the integral from negative a to a of f of x dx is equal to 2 times the integral from 0 to a of f of x dx?
Good.
And all God's children say, yes, this is a property. And the devil's children as well. Yes. Okay. We got properties under control? We'll see what you guys can do with this tomorrow. All right, so now here's the thing that we're just going to do. We're just going to play around. We're going to play around with the way that these guys are actually going to manifest themselves on the AP exam. For those of you that are like, I got this under control, I don't need your help, fine, be that way. Work on these problems. This isn't homework. The homework you already have, it's the amusement park problem. I think most of you guys are going to be ready to just go and do these. And so if you want to go solo on these, I'm going to invite you to come over to this side of the room so you guys can have some conversation. Folks that are going to stay with me, stay over here. Those of you that are going solo, or you want to work with a partner, are going to that side of the room. No one's going to that side of the room. You're like, no, you just do all the work. Yeah, okay. Thank you, Stephen, for going further to that side of the room. Carmen is following Stephen, either because she likes him, I'm just saying, or she is equally confident. Now Carmen's coming back. Okay, so mystery solved. All right. All right, number 1, find the integral from 0 to 2 of f of x dx. You have no calculator, you have no graph, you have nothing except the information at the top of the page. Take a little bit of time, see what you can do, be ready to talk. Trust your instincts here. Most of the time, they're going to serve you well.
Wait, I done got it. So,
Yeah, and I definitely need to see the supporting objection. Right? Let me get to the 11/3. I want to see this. Okay. All right. Most folks seem to be moving in a good direction. Most folks seem to have 11/3 as the answer. And 11/3 is the answer. Here's the thing though. I need to know why that's the answer. David, what did you do?
I looked at the first property
Yeah.
and how it's dated.
So the integral from 0 to 2 of f of x dx, what do you know about that?
Here, where it says for constant A, B, and C, or A. That's going to C, and B, so it means that we have those over there.
You've got the area from 0 to 1, you've got the area from 1 to 2, so doesn't this have to be equal to that integral there, the integral from 0 to 1 plus the integral from 1 to 2 of f of x dx? Is everybody okay? Everybody seeing this as like, this is the property? You're saying here, go from 0 to 2, find the area. Well, I know that the area from 0 to 1 was given to me as 4/3. The area from 1 to 2 is given to me as 7/3, so this has to be 11/3 done and done. All right, take a little bit, see what you can do the next one. I definitely want to see the notation here.
Could you?
And sometimes I'm just mean.
Yeah, can you think that there? Because you know from 0 to 2, the area is probably, you know from 0 to 3, area is 7. So could you take the 11/3 out?
oh, so 11/3. Like 0.
Yeah, from 0 to 2, the area under is 11/3.
We're trying to do 11/3 minus 7.
Right.
Which would be -10.
If you're not feeling good about this, you're going to need to take into account the area from 0 to 3. You want to get clever with this area from 0 to 3.
But this can't be right.
Why not? Why?
I don't know. It's like, I don't know. Turn.
That's right.
I need to see one.
I feel like it would be the opposite. Or it would be 7 minus 7, not 11 minus 7. So 11 minus 7.
No.
Oh,
Yeah,
okay, so
take
7.
out 11.
I was like, what are you doing?
Stop.
All right, friends, still want to keep us moving forward. They told me that the integral from 0 to 3 of f of x dx is equal to 7. I need to find the integral from 2 to 3. The clever thing to do here is split this integral in a way that is going to be beneficial to you. How can I split the integral from 0 to 3 in a way that's going to be helpful? What I need is the integral from 2 to 3.
From 0 to 2 and then from...
Right? What if I said the integral from 0 to 2 of f of x dx plus the integral from 2 to 3 of f of x dx?
No, it's still right.
Right? The part that I want is this guy over here. They told me that this part over here is, what is this, 7?
Yeah.
We figured out from earlier, it's the same function, it's the same limits, that this guy over here is 11/3. So plus the integral from 2 to 3 of f of x dx. If I subtract 11/3, I think we're going to get that the integral from 2 to 3 of f of x dx, 7 minus 11/3, was it 10/3? How many guys honestly had 10/3? Okay. But no, I don't think anybody on this side actually did it that way.
No, we just did. We
We
just did
subtracted.
7 minus 11/3.
Right? So you said in order to get the integral from 2 to 3, take the integral from 0 to 3, and subtract out this area from 0 to 2, and what are you left with? The integral from 2 to 3. And I wanted to go this way because this is a direct application of one of the properties we have. What you guys did was like a rewritten version. You're like, oh, I need this, let me just subtract from the other side. All right, cool. Number 3 of it, you guys will get real fast. The integral from 1 to 3, 4 times f of x. Right, if it's 4 times f of x, I can take that 4 out. Integral from 1 to 3 f of x dx.
Yeah, that's what I'm saying. We do the same thing.
You're going to do the same thing. We're just going to have to do a little bit of work to find out what's this integral from 1 to 3 of f of x dx. Right, so we can say it's the integral from 0 to 3 of f of x dx. But I only want to go from 1 to 3. So subtract off the integral from 0 to 1 of f of x dx. 4, this guy here is what, 7? Integral from 0 to 1.
4 thirds would be 17 thirds.
4 thirds, so 21 thirds minus 4 thirds, 17 thirds times 4.
68 thirds.
68 thirds. Okay. 4, 5, and 6 are going to go a lot faster. Andrew, are you okay back here? I have secretly removed all your friends.
11 thirds. Oh, this is 6. This is 6? I jumped to the conclusion, so I'm not sure.
Most popular wrong answer so far would be 16.
No, that's not 16.
No, it's not 16. That's why it's the popular wrong answer.
You have to, you're doing, you try to do like, the way you did it. No, it's not bad. Dude, this is 15 thirds. First of all. Yes. If you're taking in the case of a 3, 5 equals 15 thirds. You do plus 11, you get 26. Plus 5, you put it turns in 3. Of thirds, I mean.
Alright, so the key with this problem, that addition property again, the integral of a function plus stuff, it's the integral from 0 to 2 of 3 times f of x dx, plus the integral from 0 to 2 of 5 times dx. The 3 is a constant. I can pull it up front. So we've got 3 times the integral from 0 to 2 of f of x dx, plus the integral from 0 to 2 of 5 times dx. This part should be the easy part. Right, the integral from 0 to 2 we know from before is 11 thirds. So we've got 3 times 11 thirds, plus I need to figure out what this is. The integral from 0 to 2 of 5 dx. Don't fall for it. Think about the graph.
No. You're just moving, you're stretching the height.
It's the graph of 5.
You're stretching the height.
Think about the graph. The function is 5. Always 5. What you're getting is a rectangle that has a height of 5 and a width of 2. Remember that first one, the one that had the k, and we said it was k times b minus a? K is your constant, b minus a. So if all goes well, this should be 21, and looking at my solutions over there, for some reason I have the wrong answer. Don't tell anybody.
I forgot to give it.
Alright, 5 and 6 real fast.
6.
Oh, shameful.
I missed it.
Now I have to rescan.
What's an option?
Oh, it's,
I'm asking you.
I think it's
Rican.
Because you're
because if it's not functions from the same direction,
from
they're
negative
gonna
to
cancel
0,
out.
from negative 3 to 0, and from 3 to 0.
I
I just hot.
concerned about odd functions?
Because is it? What? Oh, I thought you said it equals 14. I was like, that is not. It's a number 5.
Give you
Yes,
some
'cause then
examples
you
of
do-
odd functions. Y equals x cubed is an odd function.
0 to 3.
Y equals
times
sine
x.
of x is an
Oh,
odd
right.
function. Y equals the cube of x is an odd function. Odd functions are the ones that have that rotation symmetry.
This is not a thing. This is
And
a
so if you find the area from -3 to 3 of whatever f of x looks like. Right, so the key in number 5 is the fact that f is an odd function. If it's an odd function, I was just talking to friends over here, like you're going to have rotational symmetry, meaning if this is the way the graph looks to the right, to the left, it's going to be the best approximation I can get of that reflection. Here's 3, here's -3. However much area there is here, that's positive. However much area there is there, it's negative. This guy over here has to be 0. Has to be 0. For number 6, f is an even function. We just had that conversation about even functions. If f is even, if this is what it looks like to the right, then that's what it looks like to the left. We figured out earlier that the area from 0 to 3 is 7. So that must mean that the area from -3 to 0 is also 7. It looks like I made the Bible. Okay?
I was looking at a mustache.
Or a mustache. Total area of 14. Everybody good? We're going to play around with these properties some more tomorrow. There are more to play with. Tonight's homework is an amusement park problem. It's got to be a good one. It's got to be a good one. Where's the other one? It's got to be a good one.
You're missing one.
Louis! It's got to be a good one!
missing one more.
We're still recording?
No, I already took care of it.